And welcome to SanfordFlipMath. We are talking about AP Calculus. We will be doing a fair amount of work from the Finney, Demana, Waits, Kennedy book, 3rd edition, and thank you to them for making a great book. And we're looking at section 4.3, which is obviously in chapter 4 about applications of derivatives. This specific section works with making connections between the first derivative, the second derivative, and graphs of a function. Okay, so we're going to be using derivatives to describe those graphs. We're going to be using derivatives to even sketch graphs. Okay, so the first derivative test is something we're going to spend a fair amount of time talking about, and this is something we've already dealt with. This goes back to mainly the extreme value theorem and things that relate to that. Okay, so that's really about 4.1 and 4.2. Second derivative test talks about concavity and inflection points, which has gotten mentioned here and there, but we're going to have to spend some time, clarifying that. So all of this to get to stuff about f of x. Okay, buckle up. This is going to be very abstract because we're going to need to lay down a lot of vocabulary and stuff. Okay. First derivative test is, as I mentioned, something that relates back very clearly to the extreme value theorem and also what we did in section 2 that was some of those corollaries and things related to the mean value theorem. And so first derivative test, basically it talks about a continuous function, f of x, and so that's kind of all of these rules apply that we're about to state only if it is a continuous function, okay? And we're going to focus on that continuous function at a critical point. And that critical point has an x value that we're going to talk about as c. Okay, now just a quick little reminder that a critical point is a point where y prime or f prime equals 0 or y prime does not exist. So in other words, there was either a corner or a cusp, or it goes vertical, or maybe there's a discontinuity. Okay, so everything that follows here is based on those conditions. Okay, so the first thing is if the derivative changes from positive to negative at x equals c, then f of c is a maximum. Okay, now we've talked about this a little bit already when we were working with sign charts. And just starting to get a feel for this. And the idea is if the first derivative is positive, and then it's negative as I go from left to right, and it's continuous, then somewhere in here, wherever that is, that would have to be a maximum. Okay. Now I don't know if it's absolute. It could be local. It could be absolute. I don't know. Okay. All right. That's the first part of the first derivative test. Okay. The second part now keep in mind too that could have been at a spot where maybe the derivative didn't exist. Okay, so if this is at x equals c, it's still the derivative is positive and then negative, and this is still a maximum. Okay? All right. Second part of this says something very, very similar. If f prime changes from negative to positive at x equals c, then f of c is, you guessed it, a minimum. Okay, and again the idea here is that I have a derivative that's negative, I then have a derivative that's positive, then somewhere in here has to be a minimum. Okay, so maybe there, I don't know. Okay, and again, I could have like an absolute value graph or something like that, where here's the derivative's negative, here's positive, and so in the middle, that's a minimum. Okay? Okay, moving right along, nothing deep so far. Okay, if f prime does not change sign, then there is no max or min. Wasn't that deep. Now, so in other words, if it was positive on the left side, sorry, I feel the need to do a different color since that's what I've been doing. Okay, so I have some critical point that I'm working on both sides of, okay? So maybe I'm increasing on this side, and then I'm increasing on the other side, and maybe it's something like this. Okay, so it's positive here, and it's positive there. There's no max or min there. It's just, in this case, it'd be an inflection point. We'll talk about that more in a minute. Or maybe I have something like a piecewise function. Okay, and so here, this is a place where the derivative does not exist. Here's a place where the derivative was 0. Again, positive, positive. Or for that matter, it could have been negative, negative, like derivatives negative and negative. And so there's no max or min there, again, because the derivative did not change sign. So the only way there's a max or a min, if it's continuous, inside, you know, a flow of what's going on, is there has to be a sign change for the derivative, okay? And it's fairly conceptual for that, okay? All right, continuing on. Okay, so those are the main points for the first derivative test. Now there are some special issues here, okay? One of those is if we are looking at an endpoint, okay, so now we're at the endpoint of some interval, okay? And so I could be looking at a left endpoint. If the derivative, okay, so if the derivative is negative at the left endpoint, okay, and we're going to call that left endpoint A. Okay, so x equals A. Okay, if the derivative is negative at the left endpoint A, okay, then f of A is a max, a maximum. Okay, so let's just do a little picture of what we're saying. Okay, so I'm on some graph. Here's A. It's the left endpoint. The left endpoint. The derivative from there is negative, so it's decreasing. Okay. Then that had to be a high point because I'm coming down from that. Okay. Now the converse of this is, or I'm sorry, the inverse of this is also true. If I'm saying f prime is, f prime of x is greater than 0, in other words positive, at that same endpoint or at a left endpoint. Okay, so I'm at some endpoint and then the derivative is positive, then f of A is a minimum. Okay, now I need you to just take a second and pause and make sense out of this. Okay, so you just pause, read this, make sense out of it, make a picture in your head, make sense. Okay. Okay, I'm going to trust that you did that. Okay, now, so the last thing I have to say about the first derivative test is closely related to this. It's just the other end. Okay, so we're going to talk about the right end point, B, if f prime of x is less than 0, in other words negative, at the right end point, then f of B, that y value, okay, so if that's true, then it is a minimum. Okay, so let's just do a little sketch of that. Okay, so I'm saying that at the right endpoint, wherever that B is, and if the derivative is negative, so it's sloping down to it, okay, then that guy's a minimum. Okay, and again, the inverse of this is true, so instead of negative, we make f prime positive at the right endpoint. then f of b is a maximum. Okay, so again, the idea is I have this, here's b, and if the derivative is positive coming up to it, okay, so we're going up to that point, then that's a maximum. Okay, let me just stop for a second here and say that all of this information is also on pages 205 and 206 in our calc book. Okay, so you can reference it and, you know, kind of make your brain comprehend it. Okay, that it's a big deal. This is huge. We will be referring back to this as we do examples. Okay, all right, so that's it for the first derivative test. We haven't done any examples really. Okay. Second derivative test. Second derivative test is about inflection and concavity. So let's just take a second. Concavity has nothing to do with dentistry. Oh, maybe it does, I don't know. Imagine a parabola opening up, something like this. This entire graph is called concave up, is referred to as concave up. Similarly, if I have the equation y equals negative x squared, this is considered concave down. Okay, I don't know why I decided to write y again. Okay, now some graphs switch. Okay, so for instance, if I look at y equals x cubed, it looks something like this. Okay, and this side looks like part of a parabola that opens up. It is concave up. This side, oh, it looks like part of a parabola that opens down. It is concave down. And where concavity changes is called an inflection point. Okay, so if the concavity changes, that's an inflection point. Okay, all right, so how does this tie in to calculus? Okay, well, I'm going to do just a speedy little side trip here, and then we will talk about the second derivative. If I take that equation y equals x squared, and I do the derivative, 2x, I can find out about maximums, minimums, increasing, decreasing. Well, the second derivative would be 2. This value is a positive number. And note that this one is concave up everywhere. Okay, well, what if I had the other one, y equals negative x squared. Again, derivative would be negative 2x. Second derivative would be negative 2. This is a negative number, and this graph is concave down everywhere. Okay, and one little distinction here, and then we'll lay out the second derivative test. Y equals x cubed. Well, the first derivative is 3x squared. The second derivative is 6x. And this is positive or negative depending on where we are. Well, at x equals 0, the second derivative is 6 times 0, 0. That is probably an inflection point. Well, notice this, when x is less than 0, so y prime would be like 6 times a negative number, so it's going to be a negative value. And notice on the left side of this graph, it's concave down. Where the x values are less than 0, concave down, and the second derivative is negative. If I look at where x is positive, sorry, I'm going to come back down, I just needed more room. X is positive, sorry, this was y double prime there. Y double prime is 6 times a positive number. It is positive, and the graph is concave up. Okay, so here's the issue. This isn't second derivative test quite yet, but it's related to it. Okay. If y double prime or f double prime is greater than 0, concave up. If y double prime is less than 0, concave down. That's a big deal. Okay, and again, you need to know what concavity means if you're going to care about this, and you need to. Okay. All right. So what we're going to do next is actually lay out what the second derivative test says. Okay, so I'm going to cheat a little bit here. I'm going to clone this page. Okay, and then I'm going to clear the ink off of it so I can still talk about this stuff. All right, so, wow, that was cute. Okay, so second derivative test. Okay, we talked about what things mean. Okay. Again, we're going to talk about at a point where x is equal to c. Okay, and we're back on that same continuous function. Okay, and we need to be at an interior point. We're not talking about an endpoint. Okay, and if this and what we're going to look at is specifically at critical points, at actually extremes, at a max or a min. Okay, so here we go. The idea is if so f prime of c equals 0. Okay, so I have a derivative equaling 0. Okay, so I'm at a max or a min, probably. If f double prime is less than 0, in other words, concave down, then that point is a maximum. Okay, that's it. If I'm at a point f prime of c equals 0, and if f double prime is greater than 0, in other words, concave up, I'm at a minimum. Now this, of course, begs the question, can I even do a derivative? Well, that's the only way you can look at second derivative. Okay, so let's talk about what this means. Okay, so I have some lovely graph right here, and right about here is a spot where the derivative is equal to 0. And notice the second derivative should be less than 0, should be negative, and that point is a maximum. Okay, so this is just a visual explanation for what we just saw. Okay, if I have a spot here, again, where the derivative is 0, and f double prime, this is concave up, so f double prime is positive. If that's true, then this ought to be a minimum. Okay, this is a lot of stuff to try and digest all at once. Quick note, since I did this, page 211 is where you find this particular rule talked about. Now, so what we're going to have to do is, where we're going from this is we're going to be building sign charts. We will be sketching graphs from equations. It's going to be kind of a big process. I need to leave it here, and we can talk more about this in class, and we'll start doing some examples, and my guess is we'll have another video where it's just probably 1 or 2 examples. Okay, so long process, don't freak out on me, and we're going to leave it at this. Thank you much, and we'll see you later. Bye.